Hello students, I am back with another video. This time I will be discussing questions from magnetism and alternating current which were asked in the second shift of 29 January 2023 JEE mains. So let us discuss them one by one. Here comes the first question. The electric current in a circular coil of 4 turns produces a magnetic induction of 32 Tesla at its center. The coil is unwound and is rewound into a circular coil of a single turn. The magnetic induction at the center of the coil by the same current will be. Now students, here we have to understand that the same coil is unwound and then rewound. Okay. Now due to any circular loop, the magnetic field at the center is given by mu 0 Ni by 2R, where R is the radius and I is the current, N is the number of turns in the wire. So here there are two variables we can see. What are they? N and R, both are variables. When you unwind it and again rewind it, then you will find that the number of turns will change, but accordingly the radius will also change. Suppose the number of turns increases, then radius will automatically decrease, because after all the overall length of the wire will remain same. Similarly, if you decrease the number of turns, automatically radius will increase. So since we have been informed regarding the number of turns initially and then number of turns finally, so let us completely eliminate R and express the complete what you say expression in terms of N. So now the length of the wire is 2 pi R into N. We can write like this because length of each turn is 2 pi R and multiplied by the number of turns. So from here we'll be able to eliminate 2R. 2R can be written as L upon pi N. So I'm writing this as mu 0 Ni upon 2R. 2R is L by pi N. So finally I have magnetic field at the center as this N goes up. I have mu this proportional to N square, because now L is a constant. Okay. So BC is proportional to N square. So if you know the factor of change for N, immediately you can calculate the factor of change for BC. So what is the factor of change for N? You see, initial value was 4 and final value is 1. Remember, factor of change is final value by initial value. Square it because it is square. So you have 1 by 16. So factor of change for BC is 1 by 16. That is, the new magnetic field is 1 by 16 times the initial magnetic field. So what is the initial magnetic field given? It is 32 Tesla. So just multiply it, you get 2 Tesla. So third option is the correct answer. Moving on to the next question. We have a square loop of area 25 centimeter square has a resistance of 10 ohm. The loop is placed in uniform magnetic field of magnitude this much. The plane of loop is perpendicular to the magnetic field. The work done in pulling the loop out of magnetic field slowly and uniformly in 1.0 seconds. Alright, so suppose this is the magnetic field here and the square loop is being pulled out like this. Square loop is being pulled out in this way. Okay. Now the moment, see, within the field there is no induced EMF. When the coil is well within the field, there is no induced EMF. So there is no current, and accordingly the initial magnetic moment is 0. Initial magnetic moment 0. So accordingly the potential energy initially is also 0. Incoming voice call from Smart okay. But when what happens is that when it is pulled up, just during the course of its upward motion, EMF will be induced in it, and an EMF induced will render it a magnet. The coil will become magnet because current will flow, and accordingly it will have a potential energy. So now the magnetic moment will be A into N into I. Of course there is no number of turns, so we'll assume it to be 1. Okay. So in that case, it will gain potential energy, which will be M minus MB cos 0. Okay. Formula for potential energy is minus mb cos theta. Okay, so here it theta will automatically, because it is induced EMF, theta will be 180 degree. So minus mb into 180 is mb. Okay, so a I b. Okay, right. So this potential energy is gained at the expense of work done in order to pull it out. So basically we are finding the work done in pulling out the loop in terms of the magnetic potential energy gained by the coils. Both will be same as per the law of conservation of energy. So here, so the required work done will be increase in potential energy, that is equal to AIB. So area is how much? Area is 25 centimeter square. So 25 upon 10 power 4 converted into meter square. Current is how much? Current we have to find. So current will be the induced EMF upon resistance, and magnetic field is given as 40 Tesla. Okay. Now induced EMF will be BVL. Okay. Across each of these you will be having BVL. So you can apply this concept of BVL. Basically the EMF will be induced here in this lowermost part of the wire. So this is 25 by 10 to the power 4 BVL. B is how much? Again 40. V is speed. Speed will be how much? Distance. So length of each side is 5 cm, because area is 25 cm square. Square root of 25 is 5 cm, and it is being pulled in 1 second. So this will be uh, V is 5 centimeters per second, that is 5 into 10 power minus 2 meters per second, and L is again 5 centimeters. So 5 BVL upon resistance. Resistance is 10 ohm multiplied by 40. So this is how you calculate. Okay. So you should get the final answer. Whatever it is, let us check it. Simplification will take a little time. Don't worry about that. Okay. Here 1 0 gets cancelled here. 10 power minus, sorry. Let us separate the figures first. So 25 into, I'll cancel. 25 into 40 is 1000. So 1000 and a 10 will be left here. And then we are left with 5 as a 25. 25 into 4 is 100. 100 by 10 into 10 to the power minus 4. I hope that is correct. So finally we will be ending up with 1 into 10 power minus 3 joule. So that is the second option. It's correct. Okay. Moving on to the next question. For the given figures, choose the correct options. The RMS current in a circuit B can never be greater than that in A. RMS current in figure A is always equal to that in figure B. RMS current in circuit B can be larger than that in A, etc. etc. Now you see, students, here what will be the current in the circuit A? This is A, okay, and this is B. In case of A, the current, I'll take it as I1, is 220 volt upon 40 ohm. Okay. Whereas here what will happen, you see, there is a resistor, inductor and capacitor, all the three are there. So most probably the impedance will be under root R square plus net inductance square. Okay. In such a case, here the current will be, I'll take it as I2, 22 upon under root 40 square, because R is 40, plus X net square. Okay. Now, regardless of the frequency, okay, as you go on changing the frequency, X net square will be greater than or equal to 0. Minimum value is 0. If it is 0, then I2 will be equal to I1. If it is non-zero, then I2 will be less than I1. So that means the RMS current in circuit B can never be greater than that in A. This is what RMS current in circuit B can never be greater than A. Either it can be equal or it can be less depending on the frequency. Okay. Then moving on to the next question. Coming to question number 23, an inductor of inductance 2 microhenry is connected in series with a resistance, a variable capacitor, and an AC source of frequency 7 kilohertz. The value of capacitance for which maximum current is drawn in the circuit. Now you see, students, maximum current means what? It is what is being referred? It is being referred to the condition of resonance. Resonance. Okay. So in the state of resonance, you know that inductive reactance will be equal to capacitive reactance, because net reactance will be what? 0. So here you have omega L and here you have 1 by omega C. So accordingly, you can find omega as 1 by under root LC. And once you know omega, you can find F naught. No, sorry. This is already given. I'm sorry. We have to find the value of capacitance. So C will be 1 by omega naught square into L, where omega naught is 2 pi F. This is how you calculate. Okay, so 2 into pi. Pi is 22 by 7. We have been given. We have to take like that. And frequency is 7 kilohertz. So 7 into kilohertz. So this square, again we have to multiply 2 into 22 by 7 into 7 into 10 power 3 into L. What is L? L is 2 micro. Micro means 10 power minus 6. So what will happen here? 10 power minus 6 gets cancelled here, students. 1 7 gets cancelled here, and here also 1 7 gets cancelled. And finally we are left with what? This 1 into 2 into 2 will be 4 to 22 into 22 into 2. That is 1 upon 8 into 22 square is how much? I guess it is 484. And finally, when you multiply this, finally you get as 3872. 3872. So x is, because the final answer is 1 by x farad. So x is how much? 3872. This is how you calculate this. That's all, students, in this video. Thank you so much.